what we're going to be doing is taking radicals and either adding and subtracting them or multiplying them, okay? And we have to follow some rules. So again, let's go through the perfect squares again. You should be able to come up with this list without asking me or something like that, because it's just math that you can do in your calculator. 1 times 1 and 2 times 2 and so on. So you don't memorize these. You can use a calculator to find these. 9, 10, and it keeps going. So that's the longest list. And then the cubes, 1 times 1 times 1, and 2 times 2 times 2, and so on. And we really only go, I mean, obviously with the dot, 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 it means it keeps going. But these are the most common ones, 1 times 1 times 1, and so on. And then the fourths is a really small list, 1 times 1 times 1 times 1, 4 ones. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3, I forgot. 3 to the 4th power. See, I don't have them memorized. Thank you. And 4, let's just go one more. I mean, I hardly ever see it go that far. You see 16 a lot. And by the way, even though 1 is in all these lists, we don't really use them. Because if you do 1 times something, it's going to just stay the same. So when I ask you guys to find numbers in a list that simplify it, ignore the 1, okay? So let's start with adding and subtracting. With adding and subtracting, here's the rule. Simplify the radical first. Do you think that's important? It is. Okay, so simplify the radical first. Yes. Okay, so if you look at part A, give you a second to catch up with me. You want to write this down. You see 1, 2, 3 different radicals. The rule is we have to simplify the radical first before we add, and then we can only combine radicals, add or subtract, that have the exact same radical. So let's simplify first, and then I'll explain the rest of it. Starting with 45x. If you remember, this is what we did yesterday. We take 45 and we say, okay, it's not in this list. Perfect square, right? Remember we talked about this yesterday, Kamara? If there's no number here, Kamara, what's the number? Yeah. So you don't see it there. If you want to write it there, it's fine. I'd rather you not. I'm not going to mark it wrong. But if you could not write it, it just, you want to recognize it when you see it. If there's nothing there, it's just a 2. So we're using this list of numbers. Okay, so 45 is not a perfect square. Is there a number in this list that goes into 45 equally? 9 and 5. How are you doing? That was good. Oh, she did? Okay. But you guys understand that, right? 45 is 9 times 5. Yeah. So 9 times 5. Now remember my little method of doing it. 9 is a perfect square, right? 9 is a perfect square. The square root of 9 is actually 3. I'm going to put it up here for safekeeping. I can't do anything with the 5. Now let's look at the x. What's the exponent on this x right now? 1. Can I divide 1 by 2? Does 2 go into 1 evenly? No. So this guy can't come out either. He's stuck underneath. And then we multiply. This number on top, that's going to go to the front. If there's already somebody in front of the radical, we just multiply those together. So that's 3 times 6 is 18. And by using my method of circling, it's really easy to look through all that mess and see what's left inside. Okay? So yesterday we just did a whole bunch of those, simplifying. But today we're having to simplify multiple of them, and then the adding part's really easy. Okay, let's do 12. Is 12 a perfect square? No. Does it have two factors that go into it where one of them is a perfect square. 4 and 3, right? The square root of 4 is 2. We'll put it up top for safekeeping. 3 is going to be stuck inside. So I'm just going to bring down that plus sign. The 2 goes to the front. There's nobody to multiply with, so it just goes down in the front. And the number that we circled is under the radical. One more. 20 becomes what two numbers? 4 and 5. The square root of 4 is 2. I'm going to put it up here. 5 is stuck underneath. And again, x to the first, 1 can't be divided by 2. So he just stays right where he is. So I'm going to bring the 2 down. Times 3 is 6. So that's going to be minus 6. Remember, you just multiply. And we have 5 and x, those two circled numbers under the radical. So what we just did there, Gabriel, whoever else was absent yesterday, Geo, that's what we learned yesterday. We're just going to take it one step further, and now we're going to add them or subtract them. You can only add or subtract like radicals. What I mean is, like this guy and this guy. See how they are exactly the same? Then we just do the outside numbers. It's like if you had just an x there. If this was 18x minus 6x, we'd have 12x. We don't do anything to the x. Same thing here. I have 18 square roots of 5x minus 6 square roots of 5x. That is 12 square roots of 5x. We just combined those two. 18 minus 6 is 12. Radicals just tag along. The square root of 3 is not a like term, so we just bring it down. And that would be your final answer. In either order, by the way. It doesn't matter what order your answer is in. Okay? Let's do another one. I see addition and subtraction signs. I say, oh yeah, I remember how obnoxious she was with her word first. We simplify first. Anyway, you have to. There's nothing here that can be simplified. Nothing. Okay? There's no perfect, oh, there is. There's a perfect cube right there. So remember, if there's a 3 there, we're using this list of numbers. So the cube root of 8, that's a perfect cube. When that happens, that means you're not going to have a radical left in your answer. The cube root of 8 is what? 2, right? You can count 1, 2. We bring it to the front. There's a negative in front, so that's just negative 2. The radical went away there. The cube root of 8 is just 2, and the negative in front made it a negative. Okay? 192. Now that's a number I'm not familiar with, right? I don't know that number off the top of my head. Like the square root of 4, I don't need a calculator for. Cube root of 192. So what you're doing is the same thing we always do. You're going to look for a number that goes into 192 that's in your cube root list. I don't necessarily know it. I have a key in front of me, so I know it. But if I were doing this without a key, I would just sit here and keep hitting math 4 and trying different numbers. No, that's not what I meant. I'm going to do 192 divided by these different numbers. Divide by 8. 24. But 24 has an 8 in it as well. I can divide 24 by 8 again and get a whole number. If you can do it twice, that means you haven't found the biggest number. Let's go a little higher. In fact, when I have a big number like 192, I typically don't start way over here. Let's try divided by 27. Oops. 192 divided by 27. Nope. 192 divided by 64. There it is. 64 and 3. Okay? 64 and 3. The cube root of 64, what is it? 4. Be careful because 64 is in 2 of those lists. Square root of 64 is 8. Cube root is 4. 3 is stuck inside. X to the first, stuck inside. Bring the 4 to the front. If there's anybody in front, they multiply. And my two circled numbers are under the radical. One more, 24. What number that's in the cube root list goes into 24? 8. Smaller numbers are easier. Cube root of 8 is 2. It's going to go up top. 3 stuck inside. X stuck inside. 2 comes down. If there's a number in front, they hang out together. You multiply them. And then all that's left inside is the 3 and the X. A lot of steps, right? You've got to practice. You've got to practice. Don't just copy answers. Okay, now I have two like radicals. Look, cube root of 3x, cube root of 3x. That means I can combine their front numbers. -2, sorry, you just have to be by yourself. And then I have positive 12 minus 8, which is 4. Since it's positive, I'll put a 4. And then cube root of 3x just tags along. And again, the order can be the other way around. Doesn't matter what order you write them in. Okay? That's adding and subtracting. I have one example left to do with you, and that is a multiplying. They're actually easier. Adding and subtracting, I would say, are the harder ones. Okay? So if you understood that completely, you're in good shape. If not, let me help you during homework. Okay, last problem, multiplication. The rule here is to simplify the radical last. So with multiplication, last. So our first step is just make this one big fat fraction, radical. So the numbers out in front, I have a 2 times basically a 1. So there's a 2 out in front. Keep the stuff that's in front by itself and the stuff on the inside. And then let's multiply what's left, or what's in the side. That's 4 times 8 is 32, right? I just did 4 times 8. Now I have to combine the a's. Think back to what do we do? Let me just show you off to the side. We have a to the third times a to the 7th. What are we going to do to those powers when we combine them? Add them. That's 3 plus 7 or 10. We have a to the 10th. And then same thing with the b's. 5 plus 2 is 7. So that's the multiplication part. Now we just simplify it. The way we simplified yesterday on the other problems. We're in the square root list, right? 1, 4, 9, and so on. So we have to come up with a number that goes into 32 that's in the square root list. 16. Why didn't you use 8? Why didn't you use 4, Mariana? It's not the biggest number. Some numbers have multiple numbers in that list. You want the biggest one. No, 4 times 8 is not going to work because, it will, but then you're going to have to do it again. Okay? So 16 times 2. This is a common one. I would kind of just know this one. Okay? So 32 became 16 times 2. The square root of 16 will go up top. That's a 4. 2 stays inside. Now remember how we do these variables. This is a 2 in here. We're just dividing. 10 divided by 2 is 5. No leftovers, right? Goes in evenly. 2 goes into 7 how many times? 3, with 1 left over, right? What I'm doing is 2 goes into 7 3 times with a remainder of 1. So that's where the 3 comes from and the remainder. Look at, even though there's a lot going on in that problem, if you use my way of organizing, the numbers and stuff, now you just bring everything to the front. If there's already somebody hanging out in front, we just multiply. So 2 times 4 is 8. and then a to the fifth, b to the third, tag along. That's on the outside. On the inside, what's left? 2b. Very clear. And that would be your final answer. So take your time with them. Go slow. I didn't give you a very big assignment on purpose. Mm-hmm. In your answer? Yeah. No, order doesn't matter. So just when you look at my key, if my order is different, you're totally fine. Totally fine. No big deal at all. Okay, so we're doing 11 through 21 odd. So I'm going to start with you. Yeah. 11 through 21 odd. Let's get you going here. It should kind of make sense. Listen, guys, it should kind of make sense that with adding and subtracting, you have to simplify first. Because if you just look at this as it is, there's nothing you can add. Nobody has the same radical. Okay? So you have to simplify them and then see if any of them can be added. So the square root of 2, are we ready? I'm doing homework, so I just want to make sure you guys are with me. All set up on your page and all that. Guys, come on, put your phones down. Let's do math. Evan, come on. Square root of 2, can we simplify it? There's nothing to do with the square root of 2. Sometimes you can't simplify it. That's okay. 8 would be 4 and 2, right? 2 goes up there. 2 stays inside. So far I have the square root of 2, which I cannot simplify, plus that 2 comes down in front. What is left inside would be 2. And then 50, what number can we divide into 50 that's a perfect square? 25 and 2, right? Square root of 25 is 5. 2 is stuck inside. Bring the 5 down in front. Square root of 2 there. This is a great problem. This is the problem, even though it looks pretty easy at this point because we have to add these together, so many people get wrong. What is going to be the number out in front? Would it be 7 radical 2? What would you say? It would be, I heard 7, I heard 8, I heard 9. It is 8. Guys, remember, we don't put ones in front of anything. The square root of 2, it's there. There's one of them. That's a 1 square root of 2. So you have 1 square root of 2, 2 more, and 5 more for a total of 8 square roots of 2. That's how many square roots of 2 you have. Does that make sense, Shane? Was that you? That you said 7? Geo, does that make sense? Shane, stop. Shane, I have to tell you a story later. Oh, we're doing odds. Is that what I assigned? Okay, that's fine. I'm not changing on you. I just forgot. Thanks for letting me know. Yeah? Mm-hmm. You know what they told us at our faculty meeting yesterday, guys? This is hilarious. They told us that the Department of Education has hired people to come out and check teachers' doors to make sure they're locked. And if they catch you with your door locked or propped, they're going to fine the teacher. Unlocked. Unlocked or propped open. I will get fined. I don't know. You know what they can do with their fine, Devin? No, they can take it and shove it. I don't know. But like my thing is, you're gonna find a teacher. I mean, I'm doing the best I can. You know, this door is revolving all the time. Like I'm constantly doing it, and sometimes I mess up with the turning of the key, and I make a mistake, and I don't lock it. Can you imagine if they gave me a fine for that? There are teachers that don't teach, that don't come to work on time, that leave early, all kinds of stuff. They're not getting fined, but if I accidentally leave my door unlocked, I would get fined. Oh boy. I used to be this open, half open. Okay, here we go. Square root of 5. Can we simplify that? No. Evan, join us. We're doing homework. This one can't be simplified. I'm just going to bring it on down. There's nothing I can do to the square root of 5. That's okay. 351, I believe? Yeah. 45 would be 9. How about 80? That's one we haven't seen. It's a big old number. So 80, I mean, your brain probably goes 8 times 10, but neither one of those are perfect squares. So don't be ashamed or shy or lazy to not pick up your calculator, okay? So I do it all the time. I can't remember every single factor. So you pick up your calculator and you use your list of perfect squares to divide. Mandy said it, it's 16 and 5. 4 goes into it 20 times, but 20 has a 4 in it too. So you want to find a bigger number is the whole point. The square root of 16 is 4. Bring it down front. And look what happened. All of them have the same radical. So we just do what's out in front. Eight minus 3 is 5. 5 minus 4 is 1. Can I put the 1 in front? Yeah, you can, but you won't ever see it like that. That means 1 square root of 5. 8 minus 3 minus 4, which is 8 minus 7, basically. You get that, Dylan? Yes, let me just put the key up and I will do that. Yes. So I showed the work on all of them until the end. But some people don't have the page, so let me put the 19 and 21 problem on. Can you see it?
Evan does be working and shit on his test.
I don't chill a test. How am I able to chill?
He wants to celebrate you, know what his working and getting A's on his test. No way.
That's what Brian is. I think.
Brian gets A's on everything.
That is silly, man. How do you know?
We're confident.
Evan, I would ruin you. I would pitch you in the dirt. Ow! No, yeah. It's a reasonable amount. You take some.
The class would not be the same without you. I will say that. Maybe for you, Gio.